Imagine a world where the air is thick enough to crush you. Clouds are made of acid, and the ground is hot enough to melt lead. A planet that looks peaceful from afar, shining bright in our sky, but hiding a surface more hostile than anything on Earth. This is Venus, our so-called twin planet, and for decades, it has been one of the greatest mysteries of our solar system. But here's the question that has haunted scientists and conspiracy theorists alike. Did the Soviet Union, with its daring Venera missions, really stumble upon evidence of life on Venus? Strange shapes, blurry images, unexplained readings. Some claim the Soviets found something incredible. Others say it was a massive misinterpretation, a cosmic mistake. In the next few minutes, we're diving into the untold story of what the Venera probes actually discovered, separating fact from fiction, and exploring why Venus continues to captivate the human imagination. From crushing pressures and scorching temperatures to mysterious surface photos that have fueled wild speculation, we'll explore it all. And if you're fascinated by the mysteries of space and the secrets our solar system still hides, make sure to subscribe to EvolveX, because every week we uncover the strangest, most mind-bending stories from the cosmos. So buckle up, because what the Soviets found on Venus is far stranger than anything you've heard. And the truth might just shock you. Introduction to Venus. Venus is one of the most fascinating worlds in our solar system, often called Earth's twin. Yet it could hardly be more different from our home. From Earth, Venus appears as a brilliant, shining point of light in the sky, sometimes outshining all stars after the moon, earning it names like the morning star and evening star. This brightness comes from the sunlight reflecting off its thick, swirling clouds that cloak the planet in mystery. At a glance, Venus seems similar to Earth. It's a rocky planet with nearly the same size and mass, suggesting they were born from the same cosmic neighborhood. This resemblance led early astronomers to imagine a warm, possibly water-rich world hidden beneath the clouds, perhaps even a place where life might exist. It's this idea of a sister planet that once inspired dreams of Venusian oceans and temperate climates. However, when scientists began probing this shrouded world with modern instruments, they discovered a planet of extremes. Venus's atmosphere is dominated by carbon dioxide and cloaked in thick sulfuric acid clouds, creating a runaway greenhouse effect that traps heat so efficiently the surface reaches temperatures hot enough to melt lead. Beneath those clouds, the air is so dense and heavy that the pressure at the surface is nearly 90 times greater than Earth's, like being nearly a kilometer underwater. These harsh conditions make Venus one of the most hostile environments imaginable, a scorched, crushing world where no Earth-like life could survive. Yet the mystery of how this planet evolved from a possible Earth-like beginning into a furnace remains one of science's most compelling puzzles. Soviet Venera Program Overview. The Venera program was the Soviet Union's bold and long-running effort to explore Venus, running from the early 1960s through the mid-1980s. Over more than 2 decades, the Soviets launched a series of robotic probes deep into space with the goal of studying Venus's atmosphere, surface, and environment missions that would push human engineering to its limits in one of the solar system's most hostile places. Early Venera missions had a rough start, with initial probes failing to return meaningful data. But everything changed with Venera 4, launched on June 12, 1967, which became the first spacecraft to enter another planet's atmosphere and send back direct measurements of its composition and conditions. This breakthrough provided the first scientific evidence that Venus's atmosphere was dense and dominated by carbon dioxide, information that would fundamentally change scientists' understanding of the planet. The program reached an incredible milestone with Venera 7 in 1970, which achieved the first soft landing on another planet and transmitted data from Venus's surface, including measurements of temperature and pressure, before succumbing to the extreme conditions. Subsequent missions such as Venera 9 and Venera 10, arriving in 1975, became the first spacecraft to send back close-up black and white photographs from the surface of another world. The Venera series continued to innovate, with Venera 13 and 14 in 1982 returning the first color images and even sound recordings from beneath Venus's deadly clouds. capturing rock samples and atmospheric noise before their instruments failed. Later missions like Venera 15 and 16 also mapped Venus with radar from orbit, adding a new dimension to planetary science. The scale and ambition of the Venera program cemented its place in the history of space exploration, achieving numerous groundbreaking firsts and expanding human knowledge of our closest planetary neighbor. The harsh reality of Venus. When the Venera probes reached Venus, the reality they uncovered was nothing like the lush, Earth-like world that early speculative science fiction had imagined. Instead, the surface of Venus is a blistering furnace, where temperatures routinely soar to around 450–475 C, hot enough to melt lead. This isn't just an occasional spike, it's the planet's average temperature across vast plains and rocky highlands, a direct consequence of an atmosphere so thick that it traps heat in a runaway greenhouse effect far more extreme than anything on Earth. Imagine standing on a world where the air around you isn't breathable, but instead feels crushingly heavy, like being almost a kilometer beneath the ocean's surface on Earth. The atmospheric pressure at Venus's surface is roughly 90 times greater than Earth's, meaning that objects or hypothetical explorers would be flattened under the sheer weight of the air itself. It's an environment so alien and hostile that even the most rugged earthly machines struggle to survive for more than minutes. Above the surface, thick clouds swirl perpetually, composed mainly of sulfuric acid droplets and other toxic chemicals. These clouds don't bring rain down to the lava-like plains, but they cast a dim, yellow-orange haze across the landscape, giving the rocky world an eerie, otherworldly glow. These clouds act like a suffocating blanket, preventing direct observation from orbit and masking the planet in an unending shroud of corrosive mist. Looking at the photos returned by Venera landers, the Venusian ground appears rocky, barren, and unwelcoming, flat slabs of rock strewn with coarse soil, under a sky that seems perpetually filtered through acid clouds, an environment far removed from anything human eyes have ever stood upon. The mysterious images. When Venera 13 and Venera 14 finally touched down on the unforgiving surface of Venus in 1982, they achieved more than just measurements and atmospheric data. They gave humanity its only real glimpses of another planet's ground. Venera 13 survived for about 127 minutes, sending back a series of panoramic shots that showed rocky, flat slabs and coarse soil beneath a hazy sky, along with parts of the lander itself visible at the bottom of some frames. These images remain some of the few direct visual records we have of Venus's surface. Venera 14 followed shortly after, lasting just under an hour and transmitting its own surface pictures showing terrain composed of basalt-like rocks and very little fine material. These images, though limited by technology and the extreme environment, sparked fascination across the world, revealing a strangely serene yet unmistakably alien landscape beneath Venus's thick clouds. Over the years, some scientists have looked at these photographs with a mixture of curiosity and imagination. In the early 2000s, Russian researcher Dr. Leonid Ksanfomality re-examined the Venera 13 panoramas and described a few shapes he felt changed between frames, objects he thought might resemble organic forms like a disc, a black flap, or even a scorpion. These claims were intriguing because they suggested movement or form changes in images taken hours apart. However, mainstream scientific analysis does not support these life interpretations. Experts who have studied high-resolution versions of the Venera photos explain that what Dr. Ksanfomality saw can be attributed to inanimate objects and imaging artifacts. For example, lens caps that popped off and appeared in different positions relative to the cameras, and visual noise from the cameras themselves. These are much more likely explanations than actual biological activity. In other words, while the images from Venera 13 and 14 are mysterious and fascinating, the idea that they show living beings arises more from human tendency to see patterns than from solid evidence of life on Venus. Life on Venus? Long after the Soviet probes sent back their dramatic surface photos and atmospheric readings, scientists continued to study Venus with new tools and telescopes capable of detecting tiny chemical fingerprints in its thick, swirling clouds. In 2020, astronomers made a surprising announcement. They had detected a trace amount of a molecule called phosphine high in Venus's atmosphere. On Earth, phosphine is a gas that can be produced by certain microbes living in oxygen-poor environments, which immediately raises the tantalizing possibility that something biological might be producing it on Venus as well. Phosphine on Venus isn't just a random puff of gas. Calculations by the observing team suggested that natural non-biological processes such as sunlight-driven chemistry, volcanic activity, or lightning should produce only tiny amounts of it. Far less than what was observed. That mismatch made the detection especially intriguing, because scientists knew of no conventional way for phosphine to persist in Venus's harsh clouds without some form of continual replenishment. However, it's critical to understand that this is separate from the Soviet missions. The phosphine discoveries are based on Earth-based telescopic observations decades after Venera landed on the surface, and they remain highly controversial. Some reanalyses have questioned whether the signals attributed to phosphine were statistically significant or could be explained by other atmospheric chemicals, and alternative chemical pathways that don't involve life are still being explored. Even so, the idea caught the public imagination because about 50 km above the surface, pressure and temperature in Venus's cloud layers are much closer to conditions on Earth, and theoretically could be tolerable for very hardy airborne microbes environments where some extremophiles on Earth thrive despite corrosive conditions. In short, phosphine has added a dramatic new chapter to Venus science. It hasn't proven life exists there, but it has sparked serious debate and further investigation into whether the acidic cloud decks might host some form of microbial life very different from anything on Earth. Why the myth of life persists. Even decades after the Venera missions, the idea that the Soviets may have discovered life on Venus continues to capture the imagination. Part of the reason is historical. Venus has long been considered Earth's twin because of its similar size and mass. Early astronomers, peering at the planet through telescopes, imagined a warm, watery world hidden beneath thick clouds, perhaps teeming with life. That image has persisted in popular culture, fueling speculation whenever new data emerges. Another reason myths persist is the strangeness of the Venera images themselves. The panoramas returned by Venera 13 and 14 showed a rocky, barren landscape under a yellowish haze. And certain shadows and shapes sparked human imagination. Russian researcher Leonid Sanfomality famously suggested some of these shapes could resemble living forms, though these claims were never widely accepted by the scientific community. For enthusiasts, these ambiguous images are easy to interpret as mysterious life forms, even though scientists attribute them to inanimate objects and visual artifacts. Modern media coverage has amplified the mystique. Sensational headlines about life on Venus often omit the nuances, focusing instead on tantalizing possibilities, like the detection of phosphine in Venus's clouds decades later. These stories reinforce the public's perception that Venus might harbor life, even though hard evidence from the surface remains non-existent. Humans love mysteries even on a planet that can melt lead in reality. The myth of life on Venus persists because of a mix of historical imagination, ambiguous images, and media fascination. It's a reminder that while scientific discovery can illuminate the universe, the human mind often fills in the gaps with stories far stranger than the facts themselves. The science behind it. The surface of Venus is a place where human life, and anything resembling Earth-like life, simply cannot survive. The first culprit is its atmosphere, which is composed almost entirely of carbon dioxide, with clouds of sulfuric acid high above. This creates a greenhouse effect so extreme that Venus traps nearly all the heat from the sun, turning the planet into a furnace. Temperatures routinely reach 450 to 475 C, hot enough to melt lead and most metals. The air itself is heavy and crushing, about 90 times denser than Earth's atmosphere, making Venus feel like a pressure cooker on steroids. The chemistry of Venus's surface compounds the danger. Rocks and soil are exposed to this relentless heat and the acidic environment, creating a landscape that is both barren and highly reactive. Experiments by landers like Venera 13 and 14 showed that even robotic instruments were quickly corroded and disabled within minutes. Any organic compounds from Earth would rapidly break down under such conditions, making Earth-like biology on the ground effectively impossible. Above the surface, the cloud layers are composed mainly of sulfuric acid droplets mixed with other corrosive chemicals. While these clouds have captured scientific curiosity for potential microbial life high in the atmosphere, at the surface they contribute to a toxic, unbreathable environment. Acid rain, combined with the blistering heat and crushing pressure, ensures that the planet's surface is utterly hostile to life as we know it. All of these factors together with a dense carbon dioxide atmosphere, extreme heat, toxic clouds, and reactive surface chemistry make Venus one of the most inhospitable places in the solar system. It's a world that shows just how different planets that appear similar to Earth can be, and why the Soviet Venera missions were such extraordinary achievements, surviving even briefly in conditions that no human could endure. Human curiosity in future missions. Despite Venus's extreme conditions, humans remain fascinated by this blazing world. The Soviet Venera missions demonstrated that, with enough ingenuity, it is possible to reach and study even the most hostile planets. Venus continues to captivate scientists and the public alike, because it represents a mirror to Earth's past and future, a cautionary tale about climate change, and a tantalizing target for discovery. Our curiosity pushes us to ask questions. Why is Venus so different from Earth? Could life exist in its clouds? How did its atmosphere become so toxic? To answer these questions, a new generation of missions is now being planned. NASA's Da Vinci Plus mission, scheduled for launch in the late 2020s, aims to plunge a probe through Venus's dense atmosphere to study its chemical composition and understand how it evolved. Alongside this, NASA's Veritas mission will map the planet's surface in high resolution using radar, revealing details about its geology and volcanic activity that could explain how Venus became a hellish world. Russia has also expressed interest in returning to Venus with new landers and orbiters, continuing a program that began with the pioneering Venera spacecraft. Scientists hope these missions will shed light on long-standing mysteries. For example, by analyzing cloud chemistry, they may determine whether molecules like phosphine are produced by chemical processes or possibly by microbial life high in the atmosphere. Surface mapping and atmospheric studies could reveal evidence of past oceans, volcanic activity, or other geological processes that shape the planet's extreme environment. Each new piece of data brings us closer to understanding how Venus ended up so different from Earth, and what it can teach us about planetary evolution. Ultimately, the human drive to explore Venus is a testament to our curiosity and resilience. Even on a planet where the ground is hot enough to melt lead, we continue to push the boundaries of science, hoping that the next mission might answer questions that have fascinated generations. Venus is still a world of mystery. They may determine whether molecules like phosphine are produced by chemical processes or possibly by microbial life high in the atmosphere. Surface mapping and atmospheric studies could reveal evidence of past oceans, volcanic activity, or other geological processes that shape the planet's extreme environment. Each new piece of data brings us closer to understanding how Venus ended up so different from Earth, and what it can teach us about planetary evolution. Ultimately, the human drive to explore Venus is a testament to our curiosity and resilience. Even on a planet where the ground is hot enough to melt lead, we continue to push the boundaries of science, hoping that the next mission might answer questions that have fascinated generations. Venus is still a world of mystery, and with each new probe, we peel back another layer of its secrets. The story of Venus exploration is a tale of human curiosity, ingenuity, and the relentless drive to uncover the unknown. The Soviet Venera missions gave us the first direct glimpses of Venus's surface and atmosphere, returning groundbreaking data that transformed our understanding of the planet. They revealed that beneath the bright clouds lies a world far harsher than anyone imagined: scorching temperatures, crushing pressures, corrosive clouds, and rocky, barren terrain. Despite the myths and speculations, No evidence of life was found on the surface. Yet Venus is not entirely closed to scientific wonder. Theoretical studies and recent chemical detections in the upper atmosphere, like phosphine, suggest that cloud layer life, if it exists, could survive far above the surface, in an environment that is less extreme but still alien. While this remains unproven, it keeps the conversation alive and reminds us that the universe often holds surprises where we least expect them. Venus may be our sister planet, but it's a world unlike any we know, still full of mystery, still waiting for answers. Each mission, from the Soviet Venera probes to NASA's upcoming Da Vinci Plus and Veritas missions, peels back another layer of its secrets. As we continue to explore, we are reminded of both the fragility of life on Earth and the endless questions that drive human discovery. So, what do you think? Could life exist in the clouds of Venus, or is it a world forever inhospitable? Share your thoughts in the comments below, and if you enjoyed this journey through one of the most mysterious planets in our solar system, don't forget to like, comment, share, and subscribe to EvolveX for more fascinating stories from space. The universe is waiting, and together, we can explore it one discovery at a time.